Today we're going to talk about things called a determinant of a matrix and an inverse of a matrix. We will find these things on the calculator, but I first want to show you what it's doing by hand like I did yesterday with multiplication, but then when you actually go to do your homework, it's fine to do these things in the calculator, and I'll show you how to do that as well. The notation for determinant is either we just say like DET in front of the matrix, which would say determinant, or we use these absolute value bars. So when you see just like straight lines on the side of the matrix without kind of the squared off corners, that means what we're finding is a determinant. And so determinants can only be found on square matrices. So the rows and the dimensions have to be the same. So like a 2 by 2, a 3 by 3, a 4 by 4. They can only be found on square matrices. And for a 2 by 2, what we do is we multiply the down diagonal and then subtract, multiply the up diagonal. Okay, so we do the down diagonal minus the up diagonal. So for this first example, I would do the down diagonal, so 8 times 6 minus the up diagonal, 7 times 4. So I get 48 minus 28. The determinant of that matrix is 20. Okay, so not too bad for a 2 by 2. Like, that's not a terrible process to do by hand. The calculator will do it, and I'll show you how. But on a 2 by 2, it's not that bad. On a 3 by 3, things start to get a little bit more messy because there's too many diagonals. So on a 3 by 3, the formula is given here, and I'll kind of explain what this formula is saying, and then we'll see how to do this on a calculator. So what we do is I would take the A1, ignore everything else that's in row with the A, and this stuff, take its determinant. So that's now just like a 2 by 2, focusing on that part, so we would do what we did before, where we do down diagonal and up diagonal. Multiply all that by A1. Then I subtract. Now I'm going to think about this middle thing. Ignore what's in line with it, and take this other stuff and make a matrix out of it and do its determinant. And then I would take the C, because I haven't used it, ignore the stuff that's with it, and do this stuff down diagonal, up diagonal. So do all those. And I myself always forget which one of these is supposed to be negative and which one is supposed to be positive. So it's just a big messy formula once you get into 3 by 3. 2 by 2 is not so bad. Down diagonal minus up diagonal, not so bad. 3 by 3 starts to get a little bit crazy. So we'll look at how to do this on the calculator. So I'm going to go into my calculator and enter the matrices the same way I did yesterday. If you still have your matrices entered from yesterday's homework, you probably don't want to delete those because you're going to be using those same ones for today's homework. So what I would do is go in, not to math, go into my matrix menu, and you have A through E defined from yesterday, so I would define this one as F. Okay, so to define a matrix, we go over to Edit, and I'm going to define this one as F, since A through E are already defined with yesterday's homework for you guys, not for me. So it's going to be a 3 by 3. So I enter those dimensions, and then I enter all of the numbers.
Wait, F is a -4 or -6.
Yeah. Yep. So in matrix F, I'm going to type in the problem that's on the sheet. So -4 and 6, 2, 5. 1. Okay, so I defined matrix F as being the problem that's on the sheet here. And then the way we're going to find a determinant is like we did yesterday, press second in mode, which quits out and brings you back to your home screen. Then I'm going to go into my matrix menu by pressing second, matrix, and I'm going to go over to that math menu. We haven't used that yet. And in that math menu, the first option is DET, which stands for determinant. So I'm going to hit enter. And then I have to tell it, what do I want it to take the determinant of? So I go second, matrix menu, and I choose matrix F.
close the parentheses.
You don't have to close the parentheses. It'll work even if you don't, but it's probably best to do that. And I get 126.
This is my
I got
favorite
it.
math.
This is math.
Wait, so then we don't have to do the formula, we just.
So you don't have to do it by hand. And even for a 2x2, so on the homework, if it's a 2x2, you can still do it on your calculator if you want. It's not so bad to do 2x2s by hand, but 3x3s by hand get a little bit heavy. So it's okay to do these on your calculator. All right. So that's a determinant. A determinant is a very useful thing. Some applications of a determinant is it can talk to us about the solution of a system of equations. And we're actually going to talk about systems of equations in our next lesson. So a determinant can give us some information about that. Determinants also can allow us to like find the area of a triangle, which if you know the height isn't so bad, 1/2 base times height. But if you don't know the height of a triangle, then the triangle area formulas get pretty messy and involve a lot of trig. So a determinant can actually find the area of a triangle without having to use a lot of trig. So determinants can be very useful for things. Yesterday I said one of the main kind of cool applications of matrices is in computer animation and graphics, and determinants play a big part in those in terms of transforming figures. So like making sure that your character stays the same size that he's always supposed to be, so that he's not, growing or shrinking from scene to scene. Determinants would be important with that. So then it says next our identity matrix. So identity, remember, is something that keeps a value the same. So we talked about that when we talked about our number systems unit. Then an identity is something we can do that will keep whatever we're doing the same. So when we add, our identity is 0. When we multiply, the identity is 1. When we have a matrix, our identity matrix has 1s on the down diagonal and otherwise has 0s. Again, it would have to be a square matrix. The inverse matrix. So an inverse is what we do to get back to an identity. So when we're adding, something's opposite is an inverse. So like 2 and -2 are inverses because they make 0. When we're multiplying, like 2 and 1/2 are inverses because they make 1. So when we're working with matrices, to find an inverse, we're going to take 1 divided by the determinant, and then we rearrange the values of the matrix. So here it says that we do 1 over the determinant, so we just learned how to find the determinant. Then what we do is our matrix kind of flips upside down and backwards. So B1 gets to stay where it is, and A2 gets to stay where it is, but they become negative. And then A1 and B2 swap places. So again, I'm going to show you on this 2x2 how it works, but then when we go to do the 3x3, we'll do this on the calculator. So the first thing is that I would do 1 over the determinant. Remember, the determinant is down diagonal minus up diagonal. Then, to make the adjustments here, the things on the up diagonal get to stay where they are, but we change their signs.
Can you just write 22? 1 over 22?
Yeah.
Okay.
Yeah, it will be 1 over 22. Yeah. So the 4 and the 3 get to stay where they are, but they change signs. And then the 5 and the 2 are going to flip-flop positions. So then I've got 1 over 22 times this matrix. And the other day we learned that when we're multiplying by a scalar or just a constant number out front, we just multiply each number by that. So our final answer would be 5 over 22, 3 over 22, -4 over 22, which could be reduced, and 2 over 22, which again could be reduced. Inverses will often end up having fractions as our answers. Because of that 1 over the determinant. So usually that's going to cause us to have fractions in our answers. Okay. To find an inverse of a 3x3, we would have to find the determinant, which was already kind of gross, and then the way that everything rearranges is really kind of quite a process once we have more stuff to rearrange. So once we go to 3x3, we definitely want to find an inverse on our calculator. So to do that, I'm going to go into the matrix again, and you can just put this one in as matrix F, because we don't need that last one anymore. So to enter new ones again, you go over to edit, and then choose which one you want to edit. So I'm going to edit F. I want it to be a 3x3, and then just put in all the new data. And then, as before, quit out to the home screen. So second mode quits out to the home screen. To find an inverse, what we're going to do is go second matrix and choose the one we want to find the inverse of, which is matrix F. And then that matrix button without pressing second first is actually the notation for inverse. That little -1 that looks like an exponent is actually the math notation for inverse. So it's the same button, you just don't press second before it. And then hit enter, but it's going to give me, oh, whole numbers. Awesome. I wanted it to give me fractions. If it gives you big decimals, okay, because like I said, usually it will. Of course, I wrote a perfect example here to not illustrate what I wanted to be illustrating. So if you end up having something with lots of decimals, instead of rounding those off or cutting them off, what you're going to do is press math, and that first option is to frac, and hit enter, and then it'll give it to you in fractions. Okay, so give your answer as fractions, not decimals. And most of your homework problems will be, of course, the one example that I wrote for the lesson isn't. But most of the homework problems will be. Okay? All right, questions?
Is there a way to make it so that it just does fractions all the time?
No, there's not a default to fraction mode. A little bit annoying, so you just have to select it every time.
It says that some of the problems won't be possible.
Some of the problems are not possible because a determinant is only possible in a square matrix. So if the matrix is not square, then we can't find the determinant, and if we can't find the determinant, we can't find the inverse. So tonight's homework problems, you're really only going to be able to do ones that are asking you about square matrices.